Welcome back, folks. It is time to continue our look at some 300 Blackout full-length resizing dies. Hopefully you watched video 1, or you're going to be very confused and lost. That was a long video, it was dry and it was boring, but we covered a lot of good info that we won't necessarily be covering again here today. So this is definitely not a standalone video. I'll try to hit the high points though, just to jog your memory. We have a Lee die, we have a Forster die, and we have an RCBS die. We have 11 different head stamps of brass, 10 of which we've actually formed into 300 Blackout from 223 or 556, whichever it happened to be. Here is the list of head stamps we're going to be looking at today. PPU, Wolf, Federal 556, Federal 223, PMC, PSD, Remington, Hornady, and WCC. Pretty common stuff. I tried to pick, some at least mostly common stuff. Now, when you're forming 300 Blackout, the neck thickness of your final product is the most critical thing. Or, that's what you always read. And it's been kind of well documented which brass is good and which brass is bad. So our list today, I've got two that I know are going to be bad. PPU and Wolf. All of the others are from the good list, and I expect good results with them. So here's the deal. This video was supposed to be up yesterday, but I can't seem to put a video together because I've already shot this ammunition. You can see we've got a whole bunch of empty brass. Everything's the same as the last video. So everything up to this point is just super duper boring, and I can't make a good video out of it, so I'm just going to scrap it all. I showed loading, I showed measuring crap, I showed range time, I showed frickin' slamming the bolt home 800 million times on our different head stamps. It all sucks, and I'm going to dump every bit of it, I think. We'll pick out snippets as we need them, but as far as I'm concerned, we're starting here where it gets interesting, hopefully. Now, the other thing that made this pretty boring up to this point is things kind of went exactly as I expected them to. So back to the list of 9 head stamps for today. And actually, we'll go ahead and include the ones we tested in the last video, Gemtech and Federal, and Lake City 556. This is the neck thickness that each one gives you. You can see PPU 13 thousandths, Wolf is 12. Just a little, thicker than we need. The ones that I measured at 10.5 and 11, basically all of the others we're testing, no problems at all, and that's exactly what I saw. Now, over in this box, you will notice some rounds that did not get fired. This is the PPU and the Wolf brass that I sized with the Lee die. They would not chamber. And, that's kind of what we expected. Now, the PPU that had the thicker neck, you can see a very distinct line around, not that far below the case mouth, to be honest with you. And you can see where it hit the chamber and got stuck. So these were fun to yank out, and there was no hope of getting these guys to chamber. Now, when we moved over to Wolf, they wouldn't chamber, but then when I ejected them, there wasn't any mark on the neck. Let me see if any of them gave a mark on the neck. I don't think they did. This one gave a little bit of a scuff, but I think with the Wolf brass, what held us back was the headspace. Because even though, with a full-length sizing die, you get the brass up in there, you'd expect the outer dimensions to be more or less equal, but apparently they weren't. This Wolf brass, and actually the PPU as well, just ended up with headspace a little bit longer than the others, and I think that's what stopped it with the Wolf. Now, I was surprised to find that with the RCBS and the Forster dies, I was able to go ahead and shoot this brass. So they chambered no problem, and they actually chambered reasonably clean, like it didn't feel, too mushy. So that was a little bit of a surprise. I still wouldn't use them. I would still throw them in the trash before I made 300 Blackout out of them. But with the RCBS and the Forster dies, it sized them enough to use them. All of the other head stamps gave absolutely no problems with sizing. And once they were sized, I measured their headspace, and they were the same numbers that we mentioned in the last video. So the Forster was still short, the RCBS was about right, and the Lee was too long, basically. The measurement below the shoulder that we had taken in the last video, all of that was the same. Dimensions were they were identical. Now, in the comment section of the last video, there were a couple people that, for one, mentioned some really great articles and stuff on the subject of neck tension. I'll link one down in the description. It's from like the Mid-South Shooters blog, and it's just a little article about proper neck sizing, how to determine how much neck tension you've got, and that sort of crap. And it was basically a summary of everything I'm doing and stumbling through and making hours-long videos. They summarize in a nice little article. So if you kind of want this information, but you really hate me, just go click on the article, man. There's no reason to torture yourself. He also gave a link to a video that the 6'5" guys did on their YouTube channel about a Forster full-length resizing die that's been custom honed. Apparently you can either order dies directly from Forster that are already honed to your specifications, or you can send them your die and they'll hone it out for you. Okay, minor technical difficulties for a second. My battery went dead in my little audio thingy. Let's see if I can regain my thought. We were talking about getting a Forster die honed, and what I mean is up in the neck area. We'll get into that more here in just a little bit. So both of the people in the comments had mentioned that they wished I had measured the cases after they had been sized around the neck and then seated the bullet and then taken the same measurement, the outside neck measurement, to see how much it grew whenever a bullet was seated. You know, another method of determining neck tension. That seems to kind of be what we're doing here. Is we're taking several imprecise methods and trying to come to a precise conclusion. If they all agree, that's kind of what's going on. So I went ahead with this batch of 9 head stamps and did that measurement they're talking about. So as soon as I formed them, I measured the outside neck, seated a bullet, measured the outside neck. The results were pretty fascinating. So these are the numbers I got from the Lee die. You'll see that the diameter of the sized cases, most of them were 0.330 or 0.331, except for Wolf and PPU, which were larger because of their thicker necks. But if you look at that loaded case diameter, and I don't even know how this is possible, most of them did not change at all. It looks like the Wolf brass grew by 1/1000th and the Remington grew by 1/1000th. Most likely that's just the difference in the way I was measuring it or something. But we basically saw no change. Now, the bullets didn't fall into the case, so there was a little bit there. You know, they are getting grabbed a little bit, but it's not even enough to move the case out larger. That was crazy. Now, here are the numbers for the Forster and the RCBS. You will see that across the board, that neck diameter grew either 2 or 3/1000ths. So most likely, all we really need to do with our Lee die to get the same sort of numbers out of it is hone down that expander ball a little bit to match the size of the RCBS and the Forster. I think, or at least I hope. You know, and really, we still don't even know what's good. Because, well, I'll tell you what, we need to look at the slam chart. If you guys remember the slam chart from the last one, well, we've got a new one here for today. And what I've done on this chart to hopefully make it more obvious is the blue lines represent the Forster and RCBS formed brass. The red lines represent the Lee formed brass. So it's a very distinct grouping. All of the Forster and RCBS had 1, 2, or 3/1000ths of stretch whenever I slammed them home 4 times. The Lees were all between 4 and 8/1000ths. So this is just more verification that that Lee is lagging behind in the neck tension department, and it's not grabbing a hold of these bullets as well as the other 2 dies. So at this point, we've taken calipers and we've measured the expander ball inside of our resizing die and determined that the Lee wasn't small enough. We've loaded all this crazy ammo and done all this crazy slamming home of the bolt carrier to determine that the Lee doesn't have enough neck tension. And our measurements outside the case neck before and after seating a bullet lead us to believe that the Lee doesn't give enough neck tension. I think we're ready to call it a fact. My Lee die just has an expander that is way too big. Now, another thing that I noticed with the Lee brass it all felt mushy, or, you know, it all went into battery mushy. You guys know that, what I'm talking about, right? There's that crisp sound of an AR going clean into battery, and then there's that mushy, gross sound that you get whenever either your gun's super dirty or your brass just isn't fitting your chamber very well. I got that with almost all of the Lee brass. And whenever I was doing all of my slam tests, I actually busted the crap out of my knuckles. Yeah, you see? Need a Band-Aid. Maybe a hospital visit. So, the Lee rounds were just having a hard time all the way across. Now, someone brought up a very good point in the last video, in the comments section of the last video, saying that Lee themselves, I think he had copied and pasted a email from Lee technical support or something, probably from a forum. I don't know. You know how those float around. Or maybe it was to him. I don't know. But it was a note from Lee saying that their die was never intended to form brass. So if you have problems forming brass and getting them to work in your gun, too bad. It's a product that was never designed for that. This die is designed to resize brass, either proper 300 Blackout brass or formed brass that's been formed in a, you know, a forming die or another die that actually works well for forming. I still think the die's too big, right? It could use a little shorter headspace, and this expander ball isn't going to get any smaller no matter what brass we use. So I think the die needs some work. I think them saying that it shouldn't be used for forming is a cop-out. But I wanted to bring that up because, you know, it's a good point. Now, on the subject of accuracy, I don't trust any of this data or any of this information. God, imagine having to sit there and watch me shoot all 27 of these groups. They're all the exact same load. They're all more or less an inch to an inch and a half, inch and a quarter to an inch and a half, whatever. There were just so many rounds that I couldn't really properly wait for the gun to cool down. It was a bit of a dumpster fire out there. And I wasn't really able to determine much. Or even if, let's say the Lee was just way worse than the others. Well, of course it is. The freaking bullets are moving all over the place. You know, until we get these bullets stabilized, I can't trust any accuracy data. I don't care how accurate the gun shoots. If the bullet's moving every time we slam the bolt, it's no good to us, right? Now, one thing you might have noticed in some of the pictures I showed earlier, I'm a freaking idiot. You guys know this already. I try and tell you every video just about. Our 168 grain AMAX that we were using, I thought this was a brand new box of 250. It wasn't. I ran out of bullets. So the PPU and the Wolf I ended up using the 165 grain Hornady SST. So not a perfect match. 165 versus 168 grains. The shape is maybe just a touch different. This has a cantilever where the other guy doesn't. But it was the closest match I could come up with. And it was actually just fine. The velocities with this dude were actually a touch lower, even though it's a little bit lighter bullet. The velocities were a touch lower with the SST. But we're talking about like 10 feet per second slower. So barely any difference. The excellent performance with Accurate 1680 just continued. All of our standard deviations, most of them were in that 3, 4, 5, 6 range, like we saw from the last video, which is just ludicrous. But we did see a couple in the teens. But overall, accuracy was fine. Velocities were fine. Didn't really see anything major that I want to comment about on that. Except for the fact that, I think in the last video, I mentioned that with our velocities, the Forster die was giving the lowest velocities in the last video. That continued. It was very, very slight. Usually just 3 or 4 or 5 feet per second, slower than the others, but it was still slower. So I don't really have a good explanation for that. But out of the 9 head stamps we tested today, I think 8 of them, the Forster die resulted in the slowest velocities. Okay, back to what I had mentioned a little bit ago about the Forster die being able to be honed. They're all in the press, actually. I'll tell you what, let's go over to the press real quick. So there was a really good point brought up in the last video that honestly I should have incorporated into this test, and that was about the shell holders. So the last video, the whole time we were using the Redding shell holder number 10. And I was actually just looking, like the point where this is really giving kind of a good little cam over feel. If I switch dies, it's not nearly as heavy a cam over with the Lee die, and I'm able to screw the die down a little bit more. I'm not sure yet how much difference that'll make. Okay, Lee shell holder and the Lee die screwed down basically all the way as far as it needs to go. I've got a couple pieces of Gemtech previously fired brass here. Okay, and I'll tell you what, just to double check ourselves, I'll go ahead and size a couple pieces with the Redding shell holder, so we don't have to just trust the numbers we wrote down in the last video. Okay, it's readjusted to match the Redding shell holder. All right, now, Hornady comparator time. All right, so with the Redding shell holder, 1.074 is the number I'm seeing, and that's exactly what I had written down when filming the previous video. Let's see. Yep, 1.074. So 1.074 is the number with the Redding shell holder. I'm going to feel like the world's biggest dumbass if this is significantly shorter. Well, 1.073 is the smallest number I can get with this piece. And I've wiggled it 1,500 times now. I can't get anything shorter. But this other piece is 1.072. So this is excellent news. So the proper Lee shell holder that came with the die gives us an additional 1 or 2 thousandths of additional headspace to work with. So if I wasn't an idiot and I would have thought of this this didn't even dawn on me until that comment came through. I really should have, I should have used the Lee shell holder with the Lee die. And we'll do that going forward, because we've got some more tests to do here, right? That's all there is to it. We need to sand down the expander in our 300 Blackout die. We need to try and lessen the headspace on the Forster die to a reasonable amount. The only one that's really kind of seemed to be working just fine, no need to modify anything, is the RCBS, or at least with what we know now, it seems that way. So one thing I brought up earlier in the video was the Forster honed die, offering. And I want to show you guys what that would mean. So our expander is what really matters. No matter how far the die body brings the neck in, the expander is going to get drugged through it and open it back up. So the thought behind getting a precisely honed die would be that whenever it goes all the way up in there, it doesn't get sized down so much just to then be expanded on the way out. So what it allows you to do is get it to where it just barely squeezes it in, and then whenever it's coming across the expander, it just barely squeezes it back out. So there's just less movement, and it's easier on the necks, right? It's going to work those necks a whole lot less. In order to make that a viable solution for you, though, you need to be shooting the same type of brass, or not necessarily the same type of brass, but then your neck thickness becomes even more critical, because that die body, the expander ball, everything's going to be custom sized for a particular brass thickness. So not really something we want to deal with in 300 Blackout, for crying out loud, but in other calibers with more expensive brass, or we're looking for more precision or something like that, it's might be something to think about. But for us here, we're not going to worry about it. Here's what I want to do, though. Just like I was mentioning, how the die body is going to bring that neck way in, smaller than the expander, so the expander that can then open it back up. Well, how far down does it size it? So what I want to do is pull the expander out of all three of these dies, and I want to run a piece of brass up in them and take a neck diameter. Now, the worst thing we could find, especially on this Lee die, if we find that it's already big, like it's already too big. So if it's not squeezing down the brass enough, I don't care how small the expander ball gets, it's not going to make any difference, right? We need it to squeeze it down enough so that there's enough for the expander ball to get through and size properly. I need a wrench for this, dude. Yeah, with these Lee dies, the decapping pin's always going to fall straight down, so I usually put it right there in the primary station. And then, all right, there we go. So our expander should be loose. There we go. All right, so Lee die gets a Lee shell holder. All right, so now if we put this guy up in there with no expander ball to open it back up, this guy should be pretty small. Unfortunately, I did not. I should have sized a case with each die before I pulled it out because I don't have numbers for Gemtech brass. Like back to our chart where we had sized case diameter. All right, good. It looks like it's 326. So that's at least 4 thousandths smaller than the smallest number we came up with earlier or whatever. Yeah, hopefully you get what I'm saying. So we do indeed have room to move on our expander. That dude. So this guy is small enough so that we can sand this guy down a little bit and it's still going to hit some brass. Okay, same test with the Forster. Yep, I need to put the Redding shell holder back in. All right, so the Forster die has given me 323. I need to write these down. What did I say for the Lee? 326? Yeah, 326 and 323. So let's have a look at the RCBS. All right, this guy's also 323. Hopefully this makes sense. So when, on its upward path into the die, it takes it down, like with the RCBS here, it takes it down to 323. And then whenever it gets pulled across the expander ball, it brings it up to like 330 or 331 were the most common numbers we saw. So it's moving in from fire diameter, 323, and then back out to about 30. Good. So, I mean, it seems to be like all three of these, if we wanted to mess around with the expander balls, even on the Forster and the RCBS, we've got the room. So except for the general suckiness of the Lee die that we've seen so far, I think the other thing we've learned is that the exceptional crappiness of the Gemtech brass seems to be unique, at least in our samples. So, remember last video, the Gemtech brass, even with the RCBS and the Forster die, we got more bullet movement, right? More stretch on our slams than we did with any other head stamp, period. And it was not even close. So that means either there's some specific property about this Gemtech brass that is making it more prone to round stretching, or there's something screwed up with my process to where I have prepared this brass in a manner that makes it especially crappy. And sometimes, if you read far enough down the threads about neck tension, you will see people that complain about stainless steel tumbling, smoothing off the inside of the neck too much and reducing neck tension. So maybe I've got the necks of these guys a little too slick. Maybe I need a neck brush, rough them up a little bit. Or maybe just that day, for some reason, I didn't get the lube off enough or something. But you know what? These sort of problems seems like it would be an every couple rounds sort of problem. This was consistent. We never tested one that was good. So I'm still a little bit baffled. I'm looking forward to more testing with the Gemtech before we absolutely call it crap. But at this point, it's pointing toward Gemtech's crap. If you guys have Gemtech available, if you would do that, if you just load up a dummy round with some Gemtech and maybe another sample of another type of brass, measure your overall length, and then just keep slamming your bolt home, taking overall length measurements, and see if you see the Gemtech especially crappy with round stretch. I would be interested to see your findings as well, and we're going to keep testing with it. So I think that's where we should end this video. We didn't learn a whole lot, but we covered a lot of ground. We verified a lot of things that needed verified, so that's good. I think for the next video, here's what I want to do. Here's what I want to do in the next video. Let's let's sand down our Lee expander. Let's work on this Lee die a little bit in the next video. I think I'm prepared to say that there's no hope with it in the way that it is right now. So let's sand this guy down. We will also work with our Forster die to try and get a more reasonable headspace number so it's not oversizing our brass. And I think we might bring some crimp back into things. I've got a bunch of these 147 grain M80 bullets. You know, they're not the best for accuracy, or at least so far. Haven't found anything that really shoots that accurate with them. But it's a good test bullet. Got a cantilever and all that crap. So maybe that's what we'll do in the next video. We'll switch over to the 147 grain M80. We'll switch to, just because we're out of the 168s, no other reason. We'll switch to a load that's not compressed, right? We had that heavily compressed load that might have been helping push those bullets out. So we'll switch to a load that's not compressed. We'll do our die modifications to the Lee, and we'll adjust the Forster better, and we'll probably bring some crimp into the equation. So with all 5 of those things, we'll need to, you know, do it incrementally, but I want to dream up a few tests and see if we can get to the bottom of this bullet setback issue. I mean, honestly, at this point, we don't even need to shoot any more rounds until we can figure this out. We've got enough information, we've got enough ideas and plans. So we need to get that straightened out before we get back on the range wasting bullets. All right, folks, that's where we'll leave it. I appreciate all the feedback, all the comments. I read every single one, even if I don't get to take the time to reply all the time. If you want to help support the channel, come check me out at patreon.com/reloading. Every little bit helps, and I appreciate all the support over there. And I will see you guys next time.